In the previous video, when we increased the R value of the exterior walls by 4 times, the EUI dropped less than 3%. When we doubled the R value of the roof, the EUI dropped another 2%. R46 for exterior walls or R68 for the roof is considered high performance by any standard. However, the reduction in energy consumption is not as substantial as many of us hoped for. When we changed the double pane glazing to triple pane glazing, the EUI dropped about 10%. It is a considerable reduction, but it was still much higher than the baseline, which is the average EUI in 2003. Also, if the project site is not in Des Moines, but in a hot climate, the effect of upgrading to a triple pane glazing can be substantially reduced. A lesson we learned from the previous example is that blindly applying expensive upgrades in your building envelope might not be the best strategy to reach your design goal of a high-performance building. Let's look at the simulation results again and have a closer look at the data. There are two sections in the simulation results, one for building and one for zones. In the building section, you can click on this drop-down box to select the data type to visualize. There is the EUI, total energy use, energy flows, peak loads, etc. The peak loads are useful for sizing mechanical systems. Let's select EUI. The x-axis of the graph shows each month of the year, and y-axis shows the EUI for each month. The legend for the color coding is at the bottom. At first glance, you can easily notice that the majority of the energy is consumed for heating the space, which is shown in red. This is reasonable since the location is Des Moines. The question is, how can we effectively reduce space heating? Let's switch the data to show energy flows. This graph shows how much energy the building is losing during winter, so you have to cover the deficit with heating, and how much energy you are gaining during summer, so you need to cool the space with an air conditioner to balance the heat flow. In other words, to keep the indoor space in the thermal comfort zone. To reduce space heating, we need to reduce the energy loss here. You can see that we are losing a big portion of energy through infiltration, which is shown in light purple. Let's see how much energy we can reduce by designing the building more airtight. Let's edit the zone properties and edit construction. Under the infiltration section, select air change per hour. Set the air change per hour to 0.5, which is a very strict standard. Click OK and run the simulation. The EUI dropped from 384 to 324, a 15% reduction. Let's look at the energy flow graph one more time. The factor that contributes to the most energy loss is now the mechanical ventilation. You can reduce the setting for mechanical ventilation if it is much higher than what is specified in the building code. For now, we will leave it as is. Let's use a heat exchanger to recover the energy for ventilation. Click on the fourth tab and add a DOAS fan coil unit. Let's use a condensing boiler for heating, which has a higher efficiency. Keep the cooling setting to the default values. In the air loop section, the default values for the heat recovery efficiency is 70% for sensible heat and 65% for latent heat. If you know the specs of your system, you can update the numbers, but I'll leave them to the default values. Click OK. Now you have a new heating cooling system. Let's apply it to the zone by clicking on this icon. Check the box and click OK. Let's run the simulation again. The EUI is 253, which is 11% lower than the baseline. You can also try a VRF system, to see how this affects energy consumption. After we reduce the energy loss from infiltration and mechanical ventilation, you can see that windows and the building envelope can be the next targets for optimization. You can change the windows to triple pane glazing to see how much energy you can further reduce. You can see that we can strategically reduce the EUI from 384 to the lower 200s. It is much more effective than blindly increasing the R values of the walls and roofs. When you have multiple simulation results, you can hold the control key on your keyboard and select multiple simulation results and compare them. To summarize what we learned in this example, we can utilize the EUI graph and the energy flow graph to pinpoint energy use and optimize accordingly. For this example, lowering infiltration rate and adding a heat recovery system for ventilation were very effective. For other projects in other locations, the most effective measures may vary. One thing to note is that it is rather difficult to optimize this specific building because it is a single-story building with a high surface to volume ratio. With multi-story buildings, the EUI is expected to be much lower than this.